Question 1. Now, question 1 is asking us to compute explicitly the given quantity. A, 5 factorial, 3 factorial, 0 factorial. Now, before we go into question 1, we do a recap of binomial. If I say n factorial, what I mean is multiply n by n minus 1 by n minus 2. Keep doing that until you get to 0, but 0 you put a factorial. In other words, if I have n factorial and I want to move a bit, I want to expand it a bit, I can expand it. If I want, I can even end there. For as long as when I decide to end, I put a factorial. So if I pick 5, it's the same as 5 multiplied by 4 factorial, which is the same as 5 multiplied by 4 multiplied by 3 factorial. This is the same as 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial. The only thing it does not allow is to skip a number. If I skip a number, it becomes undefined. So that if I have R, it's just another denotation. Thank you. No, I'm just having a class. Oh, okay. Yes, you got to check. Okay, okay. So R factorial is going to be R minus 1. If I want, I can end there. I can also go as far as R minus 2 and end there if I want. It's just another letter that I'm using in place of n. We include 0 because 0 factorial is 1. So it does not disturb anything. If I have n and I write R in this form, what I mean is from any objects, I want to pick R objects. And I'm trying to find the number of ways I can pick my R objects from n. And if I want to find that number, I do n factorial, R factorial, then n minus R factorial. So, this is the basic knowledge that you needed to have before you go and answer question A. So question A now is 5 factorial. Because you can reduce it in that form, we'll reduce it 4, 3, 2, 1, 0 factorial. 3 factorial, we can also reduce it 3, 2, 1, 0 factorial. Then we have 0 factorial, which cannot be reduced further. So this and that one and this, 2 and that, 3 and this. 0 factorial is just 1, so I'm not worried. I'll say 5 by 4 over 1, which is the same as 20. Now, because 3, 2, 1 cancelled with 3, 2, 1, then it was possible to write this number in the form 5 by 4 by 3 factorial. Because down here, I have a 3 factorial 0 factorial. So this 3 factorial has the same value as 3 factorial down. So then I would remain with 20 over 1, which is just 20. So the next time, if I have such numbers, I'll reduce the top number up to where it is equal to the down number and then cancel to avoid wasting my time. So we go to B. B is 12 to 7. This can be written as 12 factorial over 7 factorial, 12 minus 7 factorial. From the definition of n choose r. So that we have 12 factorial, 7 factorial, 5 factorial. Now 12 factorial can be reduced up to 7 factorial so that it can take out the 7 factorial and then we deal with the 5 factorial to remain in the denominator. So we have 12 by 11 by 10 by 9 by 8 by 7 factorial. Down here we have 7 factorial by 5 factorial. So the 7 factorial will cancel and will remain with 12 by 11 by 10, 9, 8. We are dividing by 5 factorial. So 5 by 4 by 3 by 2 by 1. We could not reduce anything further on top that could take away the 5 factorial because the numbers remaining on top do not have n factorial. The factorial was with 7 and it has gone. That's why we have expanded 5 factorial down here. And now we can start cancelling for those that can cancel. So 5 and 2 can take away 10. Because 5 by 2 is 10. 4 and 3 can take away 12. Because 4 by 3 is 12. And so we have remained with 11 by 9, which is 99, then by 8. So you can multiply. 8 by 9, you get 72. So you have 2, remainder 7. And 8 by 9, again, you get 72. So you have 72 plus 7, which is 79. As your answer then. So that was B. Then we go to C. So put C here. 12, 5, choose 3. The first thing is to get the 5 choose 3 and find what it is. This is 5 factorial, 3 factorial, 2 factorial. 2 coming from 5 minus 3. This is giving 5 by 4 by 3. And we have 3 by 2. 2 factorial is the same as 2. So the 3 factorial cancels. 2 here, 1. 2 in 4, 2. So we get 10. Implying that this is the same as 12. Choose 10. Which is equal to 12 factorial over 10 factorial. 12 minus 10 is 2 factorial. So then we have 12 by 11 by 10 factorial over 10 factorial by 2. So 10 factorial gets cancelled. Then 2 in here, 1. 2 in 12, 6. 6 by 11, we get 66 as our answer. The factorials do not have any unit. So we just write 66, 66. So that ends question 1. Do we have any query? Okay, so Precious, you can ask. You unmute yourself and ask.
Asking for the tutorial sheet, the question paper for this.
The question paper for that.
Yes.
Let me share a screenshot in the group.
All right, thank you.
Okay. Oh, someone has shared already. Okay, so someone shared a PDF, which is even better. Okay, so we continue. We go to question 2. Question 2. If k and r are integers such that 0 is less or equal to r, which is less or equal to k, prove that k choose r is equal to k plus 1 choose r minus k r minus 1. When you are given questions to do with proofs, you need to pick one side and show that it's equal to the other side. So you pick the most complicated part that you are able to simplify and get the other side. If you get the simplest side, you will not be able to make it complicated like the other side. So in this case, we'll pick the right-hand side, which is k plus 1 r minus k r minus 1. And just to remind ourselves that the left-hand side, k choose r, following the definition of n choose r, can be written as k factorial, r factorial, k minus r factorial. So that this right-hand side now can be reduced following that definition. So where there is k, we have k plus 1 for the first part. So we'll do that factorial, r factorial, k plus 1 minus r factorial, minus k factorial, r minus 1 factorial k. Now when we subtract k minus r minus 1, what we get is k plus 1 minus r, which we're going to write here, factorial. This is a fraction, implying that we need to look for a common denominator for us to subtract these two fractions. If, for example, you're adding 2 over 3 plus 3 over 9, or let me make it a bit simple. I say 1 over 6. You will find a common denominator. In this case, 6, the lowest common multiple of the number that you are given. This is because 3 can go in 6, and also 6 can go in 6. What this means is that between k plus 1 minus r factorial, k plus 1 minus r factorial, here we have no debate because they are the same. So our denominator will automatically have the part k plus 1 minus r factorial. Our debate now is, what do we get between r factorial and r minus 1 factorial? Now, in the beginning, we said r factorial can also be written as r minus 1 factorial. Just by this definition, we are sure that r minus 1 is a factor of r factorial. So r minus 1 factorial is a factor of r factorial, meaning that we will get the r factorial, which is a multiple of r minus 1 factorial. And so when dividing the first one, this whole thing here is what we have as our denominator. So when we divide there, we'll get 1. 1 we multiply by the numerator, we'll get the numerator, k plus 1 factorial, minus k plus 1 minus r factorial. In k plus 1 minus r factorial, we get 1. So the only trick part is on r factorial. So we now have r factorial divided by r minus 1 factorial. What do we get? We can write our r factorial as r minus 1 factorial, and have r minus 1 factorial here. Then this and that can cancel, so r will remain. So r multiplied by the numerator k factorial will have that. From that, we can now move. Say, okay, if we have this, then from the simplification that we had here, if our n is k plus 1, we can as well reduce it to n minus 1. So the k plus 1 that we have there, factorial, can as well be reduced and written as k plus 1, then k plus 1 minus 1 factorial. That is k plus 1, k factorial. So write it as k plus 1 multiplied by k factorial minus r k factorial. So that we have r factorial. The k plus 1 minus r also, we want to write it the same way we have done at the numerator. So we'll say k plus 1 minus r, k plus 1 minus r minus 1 factorial. So that we have k plus 1 minus r and then k minus r factorial. Because 1 minus 1 is 0. So we'll write this as k plus 1 minus r multiplied by k minus r factorial. Now the numerator has a common thing. the k factorial is common in both parts. So for the first part, we remain with k plus 1. The second part will remain with r. We divide by r factorial, k plus 1 minus r multiplied by k minus r factorial. We can clearly see that this part and this part will cancel, and we are going to remain with k factorial over r factorial k minus r factorial. If we look at this reminder that we had here, it was telling us that our left-hand side, which is k choose r, is actually k factorial, r factorial, k minus r factorial, which is what we have here. So this is just k choose r, and this is our left-hand side. Hence, the proof. Okay, now go to question 3. Question 3, before we write question 3, we must remember the binomial theorem, which says to expand this, you write it in this form: a n minus 2 minus 1, and b. So this will be b plus n choose 2 a n minus 2 b squared, 3 a n minus 3 b3 plus n choose r a n minus r br, until you get to n choose n, where there will be b to the power n. So there won't be a. In the same way, there's no b in the first term. So this is the binomial theorem, with this part as our general term. Now we can go to question 3. Question 3 is asking us to show that n choose 0 plus n choose 1 plus n choose 2 plus n choose 3. We keep adding in that order until we at n choose n, gives us 2 to the power n. The question here is, using our binomial theorem, which two numbers can we pick that will not disturb anything on the right-hand side and yet gives us 2 on the left-hand side? We only have 2 special numbers, actually 1, and then it will repeat itself. That is 1 plus 1 to the power n. This will give us n choose 0, 1 to the power n, n choose 1, 1 to the power n minus 1, 1, plus n choose 2, 1 to the power n minus 2, 1, 2. n choose 3, 1 to the power n minus 3, 1, 3. You keep going until you have n choose n, 1 to the power n. But 1 plus 1 is 2. And 1 to the power n is just 1. Multiplied by anything, we get anything. So, no matter how many times that you power 1, nothing will change about it. It will remain 1. So, you have this. And this is exactly what we have to prove. Any question? Precious.
Sir, kindly repeat what you said on the solution for this one.
Okay. So, our target was to have a 2 and the coefficients not disturbed. So, we have used 1 because when we substitute 1 in these places here, 1 will not affect the coefficients on the left of our question. So you have seen that whenever, even if we use 1 here, no matter how many times we square 1, we multiply 1 by itself to any power, it is still giving us 1. And 1 multiplied by any coefficient, we are still getting 1. That means that on the right hand side of this line, we'll just remain with these. And on the left, we'll add 1 plus 1 to get 2, which is what we have as our question. Hence, proved. As required. So, shall we now log out and log back? We only have 5 minutes, so we cannot start something new. So let's log out and log back so that we continue. Do that quickly because we won't wait long.